What's up everyone, Patrick here, welcome back. Moving on to the next video where we have to take each of these expressions, write them in simplest radical form. Now this is a series of videos, so if you didn't watch the videos before, make sure you do before watching this one, as there's going to be a lot of carryover. And if you're watching this on YouTube, you can go to the site. There's going to be a link in the description box that takes you to the site where all of these videos are in the proper order of what you should be watching. So starting with number one, we got the square root of x to the 5, y to the 6. Now personally, what I like to do is if I'm given multiple expressions like this, multiple variables, and then maybe sometimes you'll have constants, and here we don't have a constant, I like to split it up. So what we can do is we can work with the square root of x to the 5, and we can work with the square root of y to the 6 separately. Just sort of makes your work a little nicer, less hectic. And once we get the simplification for this and this, we can just multiply these, because both of these are basically, we can just multiply them. Right? Whenever you have the nth root of AB, it doesn't have to be two things, it could be four things over here, so this could be like A, B, C, D. That's just the nth root of A times the nth root of B. So we could split it up and then work with all of these separately and then combine them. And so here we have the square root of x to the 5. Now what you want to do here is you want to take the x to the 5 and you want to break it down. And the way you want to break it down is dependent on what root is over here. So notice this is a square root, so there's like an imaginary 2 there. And you want to find a number. Let me write this down. Initially, when I write this down, just as a heads up, it's going to seem like a lot and it's going to seem complex and you're like thinking about a lot of rules. But as you'll see as we go through the examples, it's just going to become second nature. But I'm going to write it down initially just so we can officially state what's happening. What you want to think of is a number that is less than or equal to 5, this exponent, and a multiple of 2, this root over here. And so what are some numbers that are multiples of 2? Well, 2 would be 1, right? 2 times 1 is 2. 2 times 2 is 4, 6, 8, 10, etc., etc. So we can start with the multiples first, but it has to be a number that is less than or equal to 5. And we want to take the highest one. So 2 would work, but 4 would also work. And 4 is the highest one. 6 wouldn't work because that's not less than or equal to 5. So we take the highest one, and so we take this x to the 5 and break it down as x to the power of 4, and then what would be remaining? X to the power of 1. Right? You add these exponents. When you have something like this, exponential rules, you're adding these. And so 4 plus 1 is 5. And so we got this 4 with this rule over here. And the reason why you want to do that, I'll show you in a sec. So we got the square root now of x to the 4 times x. And the reason why is because this here, this whole square root, we can rewrite as x to the 4x to the power of 1 over 2. And then we could take this 1 over 2 exponent and distribute it, quote unquote, to both of these. So we can rewrite x to the power of 4 to the power 1 over 2. And then x, there's like a 1 here, to the power 1 over 2. And then notice that what's 4 times 1 over 2? That's just 2. And that's why we wanted to get that 4 in order to get this to be a nice integer. And then 1 times a half, that just ends up being a half. And so this here, it actually simplifies to x squared, the square root of x. Right? That's part of the simplification for this. This term here simplifies to x squared times the square root of x. Right? But in order to take out that x to the power 2, we needed to get that 4. And that's why it had to be a multiple of 2, so that when you multiply these, this number times that 1 over 2, it's going to give you a nice integer over here. And then this just ends up being the square root of x. Right? So that's the process. And so we're just going to be applying that process to all of these. So if we have the square root now, this is the other bracket, of y to the 6, there's like a 2 over here. We want to think of a number that's less than or equal to 6 and a multiple of 2. So 2, 4, 6, 6 works. So we can actually, we don't have to break down this y to the 6 because this is already a multiple of 2. So we can take this y to the 6 and rewrite it as y to the 6 to the power 1 over 2. And then 6 times 1 over 2, that just gives us 3. And so this here is going to end up being y to the power of 3. Right? The square root of y to the 6 is y to the 3. Now, if this was like, let's say y to the 9, okay, what we would do, what's less than or equal to 9 and a multiple of 2? What's the highest number? 8. We would rewrite this as the square root of y to the 8 times y to the 1. And then applying that whole process, we would take the square root of y to the 8, which would be y to the 4, and then we'd have the square root of y by itself. Right? So that's an example, but in this case, because that 6 was a multiple of 2, we ended up just getting that smoothly without any other square roots involved. And so now going back to the original, all we do is just basically multiply these, put them in a nice format. So the y to the 3 we can join with the x to the 2, and then the square root of x we can put at the end. Maybe sometimes you'll see the square root of x at the beginning, but most formats are going to be like this. And so that ends up being the final simplest radical form for number 1, like that. And so we're just applying that exact same process. So moving on to number 2, notice that the inside of the root is the same, but now we got the third root of x to the 5, y to the 6. We could rewrite this as third root of x to the 5 times the third root of y to the 6. And we can work with both of these separately. So starting with the third root of x to the 5, what we want to do, we want to break down that x to the 5 to be a number that's less than or equal to 5, but a multiple of 3. So what are some multiples of 3? 3, 6, 9, 12, etc., etc. So out of these, the highest number that's less than or equal to 5 is 3, right? 6 is not going to work because it's greater than 5. And so we could take that x to the 5 and break it down to be x to the power of 3. What would be remaining? 2, right? 3 plus 2 gives us 5. And so from here, this would be x to the power 3, x to the power 2 to the power of 1 over 3, right? If we take that radical, change it to a rational exponent, and then we could take x to the 3, that's going to be to the power of 1 over 3, and then we could take the 2, that's going to be to the power of 1 over 3 as well. And then what's going to happen is the 3 times 1 over 3, as expected, that's going to give us an integer, like it always should, so that's just going to end up being x to the power of 1, which is just x. And then this over here, this is going to end up being 2 over 3, but then the 2 over 3, notice it doesn't simplify any further. Right? We can't simplify that fraction, and so we would just rewrite this as the third root of x squared. Okay, so the third root of x to the 5, if we simplify that, if we break that down further, that's the same as x times the third root of x squared. Right, so this ends up being that right there. Right, and you want to always, this times that, you always want to see if you could simplify that further. Sometimes this will simplify and it's going to change this answer, but 2 over 3 doesn't simplify. And so we could just take that and rewrite it as third root of x to the power of 2. Right, so that's that. And then we got the third root of y to the 6. Well, this one's going to be easy because 6 is a multiple of 3. A number that's less than or equal to 6 and a multiple of 3, it's just 6. And so we could take this, rewrite it as y to the 6 to the power of 1 over 3. 6 times 1 over 3 gives us 2, a smooth integer, as expected. So this ends up just being y to the power of 2. And so this is just y to the power of 2. Combining those into a nicer format, we could put the y to the 2 with the x, so we'd have x, y squared, and then we'd have the third root of x squared, like that. And so that ends up being the simplest radical form for number 2. All right, so moving further along to number 3, we have the third root of 27 x to the 4, y to the 7, and then z to the 10. So again, we could split these up. Third root of 27, third root of x to the 4, third root of y to the 7, and then the third root of z to the 10, like that. We could just work with those individually. Again, as you get more practice, you're going to be able to do this a lot quicker, but initially I recommend breaking it down and getting that practice of the fundamentals in. Third root of 27, well, that's just 3, which is nice. It's not always going to be a smooth number like that, but in this case it is. Third root of 27 is just 3. Third root of x to the 4, let's work with this on the side. What's a number that's a multiple of 3 but less than or equal to 4? What's the highest number? 3. And so we take this, we would rewrite as the third root of x to the 3 times x to the 1. And this would be x to the 3, x to the power 1 over 3, and then we take x to the power 3 to the power 1 over 3, and then x to the power of 1 over 3. 3 times 1 over 3 is just x. And then the third root of x, or x to the power 1 over 3, can't simplify that any further, so that's just the third root of x. So this bracket simplifies to x times the third root of x. Right, now the third root of y to the 7, I'm actually just going to take the y to the 7 and rewrite that as just 1 over 3, like that, right away. So what we want to do, what is a number less than or equal to 7, but a multiple of 3? What's the highest number? 6. So we could take this and rewrite it as y to the 6 times y to the 1, right? 6 plus 1 is 7. Then we got the 1 over 3. The y to the 6 is going to go to the power 1 over 3, and then the y to the 1 is going to be to the power 1 over 3. So this would end up being y to the 2. 6 times 1 over 3 is 2. And that's just going to end up being 1 over 3, so the third root of y. So this ends up being y squared times the third root of y, like that. And then we finally have the third root of z to the 10, which I'm going to rewrite as z to the 10 to the power 1 over 3. What is a multiple of 3? The highest number that's a multiple of 3, but less than or equal to 10, 9. And that's a 1 over there. We've always been getting these 1s. That's not always going to happen. I should have maybe made this to the 11. Okay, if this was an 11, then this would end up being 2. Right? It's just a coincidence that we keep getting this 1 over here in these two expressions, right? But doesn't necessarily have to be. So anyway, let's stay with 10. This, that, and then we got z to the power 9 to the power 1 over 3, and then we have z to the power 1 times 1 over 3, that's just 1 over 3. So this ends up being 9 times 1 over 3 gives us 3. And then we have the third root of z. Okay, so this bracket simplifies to z to the power of 3, and then we have the third root of z, like that. And so now you want to combine this into a nicer form. So the first thing, the 3, stays as is. And then you want to combine all of the terms that are without a radical. So that would be the x, the y squared, and then the z to the power 3. So we'd have x, y to the power 2, z to the power 3, and then you can actually just cross these out if you want to make sure you're not missing anything. And then notice we got the third root of x times the third root of y times the third root of z. Because they have the same root, you can just combine them under the same root. Remember, the nth root of a times the nth root of b is just equal to the nth root of ab. And these could be more than 2 expressions. We have 3 expressions here. So this would end up being, when we combine this, the third root of x, y, z, like that. So that ends up being the final answer, right? So that's basically the process. So this would end up being 3x, y to the power 2, z to the power 3, and then we would have the third root of x, y, z. Then moving on to number 4, we got the fourth root of 4x to the 6. So this one actually looks more simple than number 3, but there's actually a lot going on here. That's why I wanted to go over this example. So first thing we could do, we can break down this into the fourth root of 4 times the fourth root of x to the 6, like that. And then we could work with both of these separately. So the fourth root of 4. Remember, what you want to do with these kinds of questions is you want to see, when you have an integer here, a number, can you take that number and rewrite it in terms of a lower base? And we can. We could take the 4 and rewrite it as 2 to the power of 2. Actually, before doing that, I'm going to just take this and rewrite it as 1 over 4 to the power 1 over 4, like that. And then again, this 4, this can go 2 to the power of 2. And then you multiply these, you end up with 2 over 4, which would be 2 to the power of a half, which would end up being the square root of 2. So the fourth root of 4 is the exact same thing as the square root of 2. That's a nicer format to put it in. right? It's not always going to happen that this here is going to simplify this fraction, but in this case, it does simplify. And so now working with that remaining expression for the fourth root of x to the 6, we want to take the x to the 6 and break it down in terms of x to the power of the highest number that's less than or equal to 6 and a multiple of 4. What are multiples of 4? 4, 8, 12, etc., etc. Out of those numbers, which is the highest number less than or equal to 6? 4. So we would take the 6 and break it down to x to the 4, and then we'd have x to the 2, like that. So we can rewrite this as the fourth root of x to the 4, x to the power of 2. And so from here, let's rewrite this as a rational exponent. You don't necessarily have to rewrite it as a rational exponent. You could rewrite this as the fourth root of x to the 4 times the fourth root of x to the 2, but I like to put the rational exponent here because you're going to see this x to the 2 and that is going to simplify. So when we distribute, quote unquote, that exponent, 4 times 1 over 4 gives us 1. 2 times 1 over 4 gives us 2 over 4, which ends up being 1 over 2. And so this simplifies to x square root of x, like that, right? This and that are the exact same thing. And so in this case, it's why it helps to put this rational exponent here. We know this times that because we did that preliminary step of finding that number. We know that this times that is always going to give us an integer here. But then this times this, a lot of times is going to simplify like it does here. The 2 over 4 simplifies to the 1 over 2. Right? So this ends up being x times the square root of x. And so what we can do here is, remember, we want to first put the terms that are without a square root, so this x, so that goes away. And now we got the square root of 2 times the square root of x. Because they're both square roots, you can combine those two under the square root. So this would end up being the square root of 2x, like that. Now if this was like the third root here, and this was the square root, you can combine them. Okay, but because we started with the same root, a lot of times you're going to end up with the same root here, and you're going to be able to combine them. And so this ends up being the final answer. Sometimes you'll see this, maybe this is going to go first, and then the x would be at the end there, right? Because these are multiplying, you could put them in whatever order, so just be careful. But personally, this is the format that I like to have it in. Right? So even though there's not too many terms here like there was in number 3, a lot going on here in terms of simplification and how to get to here. Right? And then moving on finally to number 5. We got the fourth root of 7x squared y to the 3 z to the 5. So we can rewrite this as fourth root of 7, fourth root of x to the 2, fourth root of y to the 3, and then the fourth root of z to the 5, like that. And so here, the fourth root of 7, that doesn't simplify any further, right? This is not going to be an integer, number 1. And then number 2, the 7, we can't further rewrite that in terms of an exponential expression with a lower base, like 2 to the power of an integer won't give us 7, 3 to the power of an integer, 4 to the power of an integer, 5, right? Nothing's going to give us that 7. And so this doesn't simplify any further, so this would actually just end up being just the fourth root of 7. Now the fourth root of x to the 2, we actually just did that. Right? What does that simplify to? That just simplifies to the square root of x. right? Because we got that x to the 2 to the power of 1 over 4. 2 times 1 over 4 gives us 2 over 4, which simplifies to 1 over 2. So that's the square root of x. And now we got the 4th root of y to the 3. Notice in this case, this number is less than this number, right? So there's no number that's less than or equal to 3 and a multiple of 4, right? Because the multiple of 4 starts at 4. Then we got 8, then we got 12, etc., and the 3 is less than that first multiple. So we can't break that y to the 3 down, but you always want to check, can you simplify this, like we did over here, right? 3 over 4, that doesn't simplify any further. So this actually isn't going to simplify any further, so that would just stay as 4th root of y to the 3, like that. And then we have the 4th root of z to the 5. Notice that the 5 is greater than the 4, so we would apply that same process that we did before. What's a number less than or equal to 5 and a multiple of 4? What's the highest number? 4. 8 wouldn't work because it's greater than 5, but 4 works. So we'd have 4th root of z to the 4, z to the 1, like that. And this would end up being z to the 4, z to the 1 to the power of 1 over 4. So we'd have z to the power of 4 to the power of 1 over 4 times z to the power 1 to the power 1 over 4. 4 times 1 over 4 gives us 1, which is just z to the power 1. So it's just z, and then we'd end up with 1 times 1 over 4, which is 1 over 4. Z to the power of 1 over 4 gives us the 4th root of z. So this simplifies to z times the 4th root of z, like that. All right, so now we have to combine all of these. And so this is the order because again, these are all multiplying, it doesn't matter really which order they're going to be in. Personally, the order I go in is I first start with the expressions that don't have a radical, and that's going to be the z, right? So that's going to go first. Then I move to the lowest radical here, which is the 2. Right? Notice we have a 4th root, but we also have a square root here. And so we can't combine a square root and a 4th root like I mentioned before. So we got to deal with them separately. And I'll first deal with the square root. So I'll put the square root of 6, or a square root of x rather, over here. That goes away. And now we're left with the 4th root of 7 times the 4th root of y to the 3 times the 4th root of z. We could put all of those together. So 7 y to the 3 and then z. So took care of that, took care of that, took care of that. So that ends up being the final answer right there for number 5. Now, a couple of things I want to mention at this point. This can be in different formats, not just in terms of the order, but sometimes you'll see this. Notice how the 4th root of x to the 2, we simplify to the square root of x. But because there's a bunch of 4th roots here, sometimes they'll just keep this x squared under the 4th root, even though that can simplify further, maybe on a multiple choice test. Another format this could be in would be z times the 4th root of 7x squared y to the 3 z. So instead of having that square root of x there, they'll keep that x to the 2 just to make it all in terms of one radical. And so you got to be really careful here, because this may be a multiple choice answer. But this and this are the same, so this could be another multiple choice answer too. So you got to be super careful here with the formats. Know how to adjust, maybe going from this to this, this to that, just to check to make sure that your answer is correct. It's the same thing. Another final format issue that I want to mention is some textbook solutions. This is a number, right? While these are variables. And so even though they share the same fourth root, a lot of times you'll see certain textbook solutions put the number in front. Personally, I think it's kind of weird. If it's sharing it, you should just put it all under that same root. But again, some solutions might put this fourth root of 7 at the beginning. Okay, and then maybe have like z square root of x, and then the fourth root of y to the 3 z. Just to have a number at the beginning. Personally, I don't like to do that, and most profs are going to expect this format, either this format or this format. I feel like this one is the more proper one, simplifying that fourth root of x to the 2 to be square root of x. But again, just in case you run into solutions where that number is in front, sometimes they'll have that right here. Right, but again, usually the solutions are going to be in one of these two formats.